Hello guys, I'm Karthik SP from SPC and today my topic is DFA, that is Deterministic Finite Automata. Subject name is Automata Theory and Compiler Design. Subject code is 21CS51. So let's start. First, we have contents, that is DFA introduction, definition of DFA, brief overview as well as its applications, finite automata, types of automata, finite alphabet states transition functions, components of DFA, that is states, alphabet transition functions, initial state, accepting states. Later, you have examples of transitions, transition diagram representations, simple DFA with transitions, um, definition of determinisms, acceptance and rejections of the input strings, accepting states and language acceptance, example of accepted and rejected strings, equivalence with regular language, connection between DFS and regular languages, regular expressions and their equivalence with DFAs, overview of NFA, differences in transitions and determinism, conversion between DFA and NFA, brief discussion on real world applications, conclusion. So, first you have definition of DFA. DFA is a mathematical model and a type of finite state machines that describes a computational process. Consists of finite set of states, a finite set of input symbols, a transition function that describes how the automation moves from one state to another. To another based on the current states and the symbol input symbols. An initial state where the computation begins and a set of accepting states and indicates successful completion or acceptance of an input string. The deterministic nature of a DFA means at any given point during the computation, there is only the one unique transitions for a specific combination or current state of the input symbols. Overview of DFA. It has states, alphabets, transition functions, initial states, accepting states, states a finite set of distinguished conditions or configuration that automation can be. Alphabets, a finite set of input symbols or characteristics that automation can process. Transition function that defines how the automation moves from one state to another based on the current states and input symbols. The initial state, starting point of computations. Accepting state that reached indicates the successful acceptance of an input string. Applications of DFA. DFA is there in lexical analysis and compilers. Pattern matching it is mainly used in network security as well as parsing and syntax. So in lexical analysis, compilers DFAs are widely used in compilers to perform lexical analysis, where they recognize and tokenize input source code based on predefined patterns and keyword identifiers. Pattern matching DFAs are employed in strings matching algorithms, helping to effectively locate patterns on substrings within a given text. Network security, they are used in instruction detection systems and firewall matching to identify and respond to specific network patterns or signatures. Parsing and syntax, DFA plays a role in parsing algorithms, the analysis of programming language syntax and grammatical structures. Application of DFA is used in text search algorithms, regular expression engines. DFAs are utilized in algorithms like uh, Ascorsic algorithm, which efficiently search for multiple patterns in given text simultaneously. Regular expression engines DFS are implemented in regular expressions engine to match input strings against the regular expression, providing powerful tools. Basics of finite automata. Finite automata is a mathematical model used to represent a study's computational process. It is a theoretical construct that simulates a machine with limited memory capabilities of transition between different states based on input. Finite automata and essentials in the field of formal language theory and automata theory for understanding the capabilities and limitations of computation. Types of automata, that is DFA as well as NFA. In DFA, transition from one state to another is uniquely determined from current state and its input symbols. In NFA, allows possible transition from a given state with specific input symbols. Finite set of states, alphabets, transition functions. Uh, finite set of states, the automation has a finite collection of distinct states, each representation of specific condition or configurations. Alphabet set of input symbols or characteristics the automation can read. Transition function defines how the automation moves from one state to another on the current state and the input symbols. Later, you have components of a DFA. Set of states denoted as Q represents its distinct conditions or configurations that a DFA can be in during its computations. The automation denoted as the sigma is a finite set of input symbols or characteristics that DFA can recognize. The transition function denoted as delta is a mathematical function defines how DFA moves from one state to another based on current state and input symbols. Initial state denoted as Q0 is starting point of computation. Accepting state is set of accepting states denoted as F, represents state in which DFA signals the successful recognition or acceptance of input streams. Transition functions in a DFA. DFA transition is a deterministic finite automata is a crucial aspect that detects how the automation transitions from one state to another based on current states and input symbols. Let's explore the formal definition provides examples of transition and discuss their representation based on a transition diagram. Later, you have formal definition. Formal definition transition function denoted as delta is a mathematical model maps the Cartesian product or the set of states, the alphabet to the set of states. Examples of transitions. Let's consider a simple DFA with states, an alphabet and the following transitions, whereas delta equals to Q1, delta equals to Q0, delta equals to Q2, delta equals to Q0, not delta equals to Q1, delta equals to Q2. Transition diagram representation. So here is a transition diagram representation, step-by-step explanation how it's processing or input strings. Delta equals to Q1, Q0, delta equals to Q1, delta equals to Q1, delta equals to Q2, later delta equals to Q2 and as well as Q1. Transition diagram. Uh, it starts with current state equals to Q0. Later read the first symbol delta equals to Q1, later new state equals to Q1. Read the second symbol delta equals to Q2, new state equals to Q2. Read the third symbol transition delta equals to Q2, new state equals to Q2. Transition delta equals to Q1, new state equals to Q1. Read the fourth as well as fifth symbol delta equals to Q1, new state equals to Q1. Read the sixth symbol transition delta equals to Q2, new state equals to Q2. End of inputs final state is Q2, which is an accepting state since the number of ones is even. Conclusion: the input strings 1101 is accepting by the DFA as well as finite states of accepting states. Deterministic nature of the DFA definition, deterministic uniqueness of transition DFA. Definition of determinism in the context of deterministic finite automata refers to the uniqueness and predictable behavior of the automata when processing input symbols. In a deterministic state, there is no ambiguity or choice regarding the transitions of the automation should make. This deterministic behavior improves the analysis of automation's operations and contributes to the clarity of its processing rules. Uniqueness of transition in DFA, language recognition acceptance, and rejection of input strings acceptance states and language acceptance examples of accepted as well as rejected. Language recognition in DFA, acceptance in after processing the entire input string, the DFA is in an accepting string, the input string is accepted. Later in rejection, you have if at any point during processing or after processing the entire input string in DFA is not an accepting state, the input string is rejected. Accepting state and language acceptance. Set of accepting states is crucial. Accepting states 1101 processing goes from Q0, Q1, Q2. Final state is Q2. Conclusion string is accepted as a final state as an accepting state. Rejecting state is 101 where processing is Q0, Q1, Q0. Final state equals to Q0. Conclusion string is rejected at the final state is not an accepting state. Later, equivalence with regular language, connection between DFS and regular languages, expression and the equivalence with DFS. In equivalence with regular expression, DFS and the regular language are closely connected and exists a strong equivalence between them. Both DFS and regular language are formal models that describe certain class of language. Connection between DFS and regular languages. A language can be recognized by a finite automata or a subset of NFS are both DFS and NFS recognize exactly the class of regular language. Regular language can also be described using regular expressions, which are another formalism of defining languages. Regular expressions and their equivalents with DFS. A regular expression is a concise way of representing a regular language. Regular operations include union, concatenation, and clusters. Equivalence between regular expressions. DFA is established through notations, and a regular expression corresponds to DFA vice versa. Equivalence DFA to regular expressions. Given a DFA, there is an algorithm to construct an equivalence relations. Regular expression that describes the same language recognized by the DFA. Equivalence the regular expression to the DFA. Given a regular expression, there is an algorithm to construct an equivalent DFA that recognizes the language described by regular expressions. Example, consider a DFA that recognizes strings over the alphabet by last symbol. Comparison with NFS. Overview of NFA differences in transitions and deterministic conversion between NFA and DFA. Overview of NFA. It states a finite set of states representing various conditions of configurations. Alphabet, finite set of input symbols or characters. Transition functions describes how the automation moves from one state to another based on current states and input symbols. Initial state, starting point of computation. Accepting state that indicates successful completion or acceptance in the input strings. Differences in transition and determinism. Transitions, main difference lies in the nature of transitions. Determinism, DFS are entirely deterministic, meaning that the transition from one state to another is uniquely determined by its current symbol from its input symbols. Conversion between NFA DFA is a process that allows you to switch between two types of finite automata while the preserving the recognized languages. NFA to DFA, you have epsilon closure, transitions accepting states, transitions accepting states. Epsilon closure. Each state in the NFA finds the epsilon closure, where it is a set of states reachable from the original states through epsilon transitions. Each set of states obtained from the epsilon closure determines the possible transitions for its input symbols. Accepting state, if any of the state is an accepting state in the NFA, that set becomes an accepting state in the DFA. Each state in the DFA becomes a state in the NFA. The transitions in the NFA mirror throws of the DFA, with one exception for each transitions in the DFA, with create an equivalent at each transitions in the NFA. Accepting states in the DFA becomes accepting states in the NFA. Conclusion, a recap of the key points, the importance of DFAs in computer science. Importance of DFA in defines set of states, alphabets, transition functions, initial states, and accepting states. Recognize a set of language processing inputs in strings in a deterministic manner. Components of DFA states, alphabets, transition functions, initial state, accepting states. States represents various conditions or configurations. Alphabet set of input symbols or characteristics. Transition functions govern state transition based on the current state and input symbols. Initial states the starting point of computation. Accepting states indicate successful completion or acceptance. Uh, Key important points, the continuation is used in deterministic nature, language recognitions, equivalence with regular languages, unique transition for each state and input symbol pairs contrast with non-deterministic finite automata, allows multiple possible transactions, language recognition, acceptance and rejection of the input strings based on reaching or not reaching accepting states. Accepting states plays a critical role in determining language acceptance. Equivalence with regular language are equivalent to regular language. It can be used to describe the same set of language recognized by DFA. Conclusion, you have a comparison with NFA allows a non-deterministic transition while DFA is entirely deterministic. Conversion between NFA and DFA enables the flexibility and clarity in language recognitions. Lexical analysis and compilers are extensively used in compilers and for lexical analysis, where they tokenize source code based on predefined patterns. Pattern matching plays a crucial role in algorithm for efficient pattern matching in various applications. Network security used in instruction detection systems. Conclusion: importance of DFA, parsing and syntax analysis, text search algorithm, regular expression engines. Employed in parsing algorithm, uh, analysis program language syntax and grammatical structures. Applied in text search algorithms such as Corsic algorithm for efficient multiple pattern matching. Regular expression engines implemented in regular expression engines, providing a powerful tool for text processing and search operations. Theoretical theoretical foundations. DFS are foundationals in formal language theory and automata theory, providing a theoretical framework and understanding computational process. So this is the end of the slide. Thank you. Have a nice day.